David, I introduced you to my favorite student. Her name is Ann Serkey. She gets everything right. Think about it. All right. Ann Serkey. Ann Serkey. Nothing. Okay. What would A plus B look like? And I said all I'm looking for is the diagrams. Now I'm going to be fussy. If you didn't put arrows on your vectors, I'll take a half mark off because I've learned that leads to sloppy mistakes and it's so little work to put them on there. What would A plus B look like? It seems to me that vector A looks like that. Vector B looks like that. So if I see that and then a resultant going that way, I would give you 1 mark. What would B plus A look like? Well, B plus A would be vector B plus vector A. In fact, your resultant for number 1 and number 2 should look identical, which to me kind of makes sense. Darman, what's 3 plus 5 in your head? What's 5 plus 3 in your head? When you add numbers, does the order make a difference, or do you get the same? When you add vectors, does the order make a difference? No. By the way, what's 5 take away 3? What's 3 take away 5? -2. Order matters when you're subtracting, and we will talk about how to subtract vectors today. So we can be casual when we're adding. We need to be a bit more meticulous when we're subtracting. C plus B, well, I add them tip to tail. So vector C looks like this. Vector B looks like that. I guess the resultant would be at an even steeper angle like that. How would you find that? This one would not work for SOHCAHTOA. Well, you'd have to do a workaround. There's something called the component method, which I'm going to show you today. Or you would use non-right-angled trig. You'd use the sine law and the cosine law. B plus C should give me the same resultant because the order doesn't matter. Let's see. That would look like this. There's vector B. There's vector C. There's the resultant. A plus C. Okay. There's vector A. There's vector C. I guess, oh, you know what? I should probably draw A a tiny bit longer just to be better to scale. Kind of looks like that, yes? Is that a hand up? Yeah. Okay. Can you get your elbow off of the desk? That's a hand up. This is, I'm adjusting hair number 93 because I'm going bald. This is, okay, good. Yeah. I purely put that in there so that you could see that it was going down at about roughly a 45-degree angle, just to give you a frame of reference. So if you put it in, that's fine, but you don't need to. And also because we don't have any numbers, being more specific right now would be kind of, meh. I just want to see, can you draw it? I'm going to assume if you have the numbers that you can do the SOHCAHTOA trig and actually get the right answer. A plus B plus C, okay. Here's vector A. There's vector B, there's vector C. You know what? I think it would kind of look like that. It almost looks like C twice as long as C, almost, I think. Oh, how do you add 3 vectors together? Tip to tail. Or add 2 of them, get an answer, and then add the third one. What do you think 2A would look like? Yeah, so how do you multiply a vector by a scalar? You draw it as many times as the scalar. So what's a vector times 3? 3 of them. What's a vector times 3.5? 3.5 of them. So it would look like this. 1, 2. If you drew a resultant over the top, that's fine. If you just drew the 2 of them, I'd live with it. What do you think A plus D will look like? As a number, then. If you left it blank, nothing, I'm good with that. If you said 0, I'm good with that. If you drew it, well, Mason, it would be like that and like that. So if you ever end up back where you came from, that'll be 0. If you're doing a bunch of vector forces and your vector triangle ends up back where you came from, that means a net force of 0. Now you know Newton's first kicks in, it's not accelerating. B plus D. Okay. B plus D. Now, I don't know if you saw what I did. I started to draw right here, but I said, oh, wait a minute. D wants me to go to the left. I need to move over. I'll do B over here so I have enough room to go tip to tail to the left. So, Danica, you want to kind of get in the habit of imagining what it's going to look like before you start to draw so that you're not suddenly ending up off the page or something like that and having to redraw it. Is that right? Yes? 2B, or not 2B. Hey, that's funny, Mr. 1, 2. 2C. 1, 2. About a 45-degree angle. 2A plus D. I guess it would be 1, 2. You know what? I think 2A plus D is the same as 1A. And if you drew the resultant in, that's fine. Here, because they're linear, if you just drew it and didn't draw in the resultant, I'm not going to freak out because they're all overlapping with each other anyways. Can you give yourself a score out of 12, please? If you need to lawyer with me, now is the time. Recall, I was only a scalar until you came into my life and gave me direction. You are the vector of my soul. How is that not a song already? You are my vector, my only vector. Give me direction. Oh, man, how is that not a song? I leave it to one of you who's musical to write a hit. Okay. A person walks 6 kilometers north. You know what? As soon as I see a north, nice try. North, east, south, west. Person walks 6 kilometers north and 4 kilometers east. What's their distance traveled? You'll notice I didn't give you much room, and that's because, Amrit, you should be able to do this in your head. What's their distance traveled? I know, I caught you zoning out. That's why I brought you in here, okay? Person walks 6 kilometers north and 4 kilometers east. I didn't give you much room on purpose. What's their distance traveled in your head, please? I'll give you a hint. More than 9 and less than 11. Ideally, that many fingers on your... Yeah, okay. More interestingly now, what's their displacement, magnitude, and direction? How are we going to do that? We're going to dulp. I'm going to write it in the same order they gave me. So 6 kilometers north plus 4 kilometers east. Amrit, how should I draw these if I want to add them together? You don't say. Oh, you're so clever now that you're paying attention. Find the resultant on your own. I'll do it up here. Oh, where's the theta going to go? Bottom left or top right? Pardon me? Can't be either. And Mud's going to keep the phone away for the remainder of class, right? Like in your pocket away. Yeah. Where is it? Theta always goes where the vector is originating from. In this case, bottom left. Color, 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 color. All right. Solve. I'll do it up here. Let's see if we get to the same place. Again, if you're comfortable doing Pythagoras without writing anything down in your homework, I'm good with that. Or, Braden, if you drew the 4 first and then the 6, you might also get 90 minus 33 points, 56.3 degrees north of east, and I would take that as well. But it's not either angle. It still has to be where the vector is coming from. I got to be fussy. Otherwise, you'll have the what of what wrong. So that's what we did last day. Hopefully no big surprise. How do we subtract vectors? The short answer is, you're right, we don't. There is a subtraction rule, and it's how I was taught in university. But then I had somebody say, I had a colleague say, hey, Kelvin, instead of teaching them an entirely different rule, why don't you just teach them how to change any subtraction into an addition? Look up. 3 take away 5. How can I turn that into an addition question? 3 plus what? You said it. Negative 5. I can turn any subtraction into an addition by adding the opposite. And in fact, that's what goes in the blanks here. Instead, we're going to add the opposite. And then how do I add two vectors? Draw them, everybody, tip to tail. In symbols, we would say this. Oh, and if I have vector A minus vector B, I'm going to do vector A plus the opposite of vector B. And what do I mean by the opposite of vector B? It's actually pretty obvious. What's the opposite of south? What's the opposite of west? There you go. So let's do one. Example 2. Suppose F1 is 6.8 newtons due west, and F2 is 12 newtons due north. What's F2 take away F1? First of all, I see compass directions, so I'm going to put a compass rose. I mean, if you already have one on your page, I guess that's fine. But on my screen, if I don't have one, I stick it on there. I'm not going to do F2 minus F1. What I'm going to do is F2 plus the opposite of F1. Zach, what is F2, magnitude and direction? F2, magnitude and direction. Because order matters when we're subtracting, and they want me to go F2 minus F1. What is it? Okay, so don't make that. That was a sloppy mistake. Don't do that, right? 12 north, you say? I agree. Plus, what's F1 as they gave it to me, magnitude and direction? What do you think negative F1 will be? 6.8 newtons due? Yep. There, I've turned it into an addition question. And I'll bet by now, Zach, even you know how to add two vectors together. Draw them. Yep. And I get that. This is F2 take away F1. Kai, where's the theta going to go? Bottom left or top right? Has to go bottom left where the vector is coming from. Color, 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 color. And now hopefully we're in pretty familiar territory. Little Pythagoras, little trig, and we're good. Mr. Dueck. Yes, Kai. What is the subtraction rule? Just curious. I knew you'd ask. Okay, don't write this down, but for what it's worth, here's the rule. You add them tail to tail. So I have 6.8 west, the original, 12 north, and the resultant is from the tip of the shorter one to the tip of the longer one. That gives me the same line as you guys all have, but why would I make you memorize an entirely different rule when, with no effort whatsoever, I can turn any subtraction into an addition question? I had a pretty good physics college prof, but that's one to me he slipped up on. I wish he would have just said, I can turn it into something I already know. Where do you use this? Ooh. Ah. Yeah. Hey, Nick, what's example 3 asking me to find? I'll give you a hint. What is, and then read me the thing after that. Now, I didn't get to this last year on the quarterly system, which is why I picked on you, sorry. First of all, what is that little triangle and a breve for? What Greek letter is it? First, delta. You can say delta V, but what does it mean? I heard it here because I did it last quarter. I did it last semester. Change in, okay? Did I put this on your sheet or I can't remember. On your blue sheet, not on your yellow sheet, but on your blue sheet, you might want to make a little note that delta, which is change in, always means final minus initial. Change in anything is final minus initial. Change in velocity is the final velocity minus the initial velocity. Change in voltage is the final voltage minus the initial voltage. Change in momentum, also called impulse, is the final momentum minus the initial momentum. And so, Nick, when this says delta V, what I'm going to be doing is I'm going to be going V final minus V initial. What am I going to be writing? V final. I knew I could count on you to get the next step. That's also why I picked on you. He said V final minus, no. V final plus the opposite of V initial, because that's how I subtract vectors. So here is one instance which I might ask you to find a change in on your test, and that would be a way for me to say, can you figure out how to subtract vectors? I've scrolled down, so I'm going to put a compass rose on. V final is north. Yoink. Plus V initial is east, so negative V initial is going to be west, and 17 is about half of 36, so I'll make it roughly half as long. Yes. Now, Nick, how will I add these two vectors together? Draw them. There you go. I changed my subtraction into something I already know how to do. So I got 39.8 meters per second magnitude, 25.3 degrees west of north. Now, if you missed that this was subtraction, because you didn't remember that change in anything is final minus initial. If you added these, you would have got 39.8 degrees east of north. If you're ever doing a question and you check my answer and you notice that your magnitude matches me, but your directions are a bit off, first thing you want to check is maybe you missed that it was a subtraction question in disguise. Okay. So that's one way I can do a subtraction question. I like that question, I like that question, I like that question. But now let's get to the meat and potatoes, vector components. We can break any slanty vector up into its vertical. I'll use the letter Y to abbreviate for vertical, like on a graph. And its horizontal, I'll use an X to abbreviate for horizontal components. Let me give you an example. Example 4 says, find the vertical and horizontal components of this vector here. So it looks like we're 42 meters per second. That's a speed, or it's a velocity, 38 degrees above the ground. Is this a slanty? Yes. Components. Here's what it's going to look like. I'm going to draw a horizontal component, dotted line, d, like that. And because it's a velocity, I'll use the letter V. Because it's horizontal, I'll subscript it with an X. And then tip to tail, d, I'm going to go up, put an arrow on the end of the up line, and I'm going to call that VY. And my argument is that slanty vector, 42 meters per second at a 38 degree angle, that came from those two mystery vectors when I did the Pythagoras and the trig. Is that okay, Xavier? Xavier, what do you want to find first, Vx or Vy? Doesn't matter, pick. Vy. Vy? Okay. Color. Vy, opposite, adjacent, or hypotenuse? Yes. What about that 42? Yep. What about Vx? Don't care. I don't know it. I'm not interested in it. I'm just going to label the two sides that I know, or that I'm interested in. O and H. Which trig function? Sine. Yep. What always goes next to the trig function? The angle, which in this case is, and that's going to equal Vy over 42. How would I get the Vy by itself? Yep. If you can do that without writing that step out in your homework, I'm fine with that. In other words, if you can draw a little arrow and say Vy equals 42 sine 38, 25.9. Did I type that in right? Yeah, I'm good. I mean, 25.857781. I'll go to, usually I carry extra sig figs because I'm often using these to find more answers, but here I'll go to 3 sig figs, 25.9 meters per second. Now, Xavier, let's find Vx. I guess that's going to be A. Which trig function? Well, I could use tan, but I'd be using Vy to find Vx, which means if I got Vy wrong, I got this wrong. I think I'm going to use A and H, which is, of course I will. Vx over 42. In fact, you know what? I think, because I would just times the 42 over, I can just backspace, edit, and change the sine button to the cosine button and save myself some typing. And I get 33.1. I could do a quick check. What that means, Zach, is if I go 33.1 squared plus 29.5 squared and then square root, that should give me the original, what was it? 40, oh, did I type that in wrong? No, I didn't. Oh, I wrote 29.5. It's 25.5. I totally wrote down the wrong answer. Geez, do it. People on YouTube were screaming at me. Let's try that again. If I go 33.1 squared plus 25.5 squared, and then square root, I get close to 42, but because I rounded this off, I won't get bang on. If I kept all my sig figs, I would get bang on. But I can do a quick Pythagoras check if I need to. Did I make another dumb mistake? 25.9. I can't even read my own writing, Danica. Duick. Getting old. 25.9. And then square root. I was going, this seems way off. There, just over 42. So yeah, assuming you don't make like 2 or 3 mistakes and can read your own calculator and don't, then you can always do a quick Pythagoras check. Okay? These are vectors, and normally I would say, where's the direction? The direction is in the subscript. The y tells me, oh, this is vertical. The x tells me, oh, this is horizontal. If this was pointing downwards, I would just stick a negative in front of it. If this was pointing to the left, I would just stick a negative in front of it. So you don't need to do the what of what. That's the components. All right, find the components of this force here. Horizontal and vertical. Again, I'll break it up into d. I almost always do the horizontal one first if I can, just so that everything looks the same. It's a force, so instead of Vx, I'm going to use Fx for force. d. It's a force, I'll call that Fy. Sarah, what do you want to find first, Fx or Fy? FYI. Okay. Color. Fy opposite, 39.6 hypotenuse. Sarah, which trig function? Yep. What always goes next to the trig function? The angle. It's going to be Fy over 39.6. I guess it's going to be 39.6 times the sine of 18. And I get 12.2 newtons. Sarah, which trig function will I use to find Fx? Of course I will. Cos 18 equals Fx over 39.6. Hey, I can just backspace and edit. Well, that's convenient. And I get 37.6618, I guess 37.7. Newtons. So, Zach, where do we use components? Next page. Components can help us to add vectors that are not at right angles to each other. So example 6, I like example 6, I like example 6, sorry. Example 6 is a non-right angled triangle. How can I tell? I saw an angle, I glanced, I saw a theta. I will put those on your quiz. I don't think I'm going to give you one on your test right now. So when I say I like this question, I like this question, I like this question, in a non-COVID year, I would also probably put one on your test, but I'd have more time to saunter through this and I'll be merciful. I guess it wants me to add, Kevin, add what? 14 newtons west? Oh, I see a compass rose coming up in my future. And Kevin, can you read to me the second vector, starting with the word 24? 30 degrees what? South of what? South of what? Keep repeating it. I'm not making fun of you. I'm making a point. South of what? South of what? That's going to be your line. I'm going to come back to you. All right. Let's do the first vector. It wants me to add 14 newtons west. I guess that's going to look like this. 14. 24 newtons, 30 degrees south of what? South of what? South of what? How do you draw these? You do the of west first. Everybody draw a little dotted line going west. Oh, I'll put a plus sign so I know I'm adding vectors. What of west, Kevin? South of west. Go back to the beginning of your dotted line. I'm going to drop down south. How many degrees? 30 degrees, and this line here is 24, so my scale is terrible right now. It should be longer than the 14 by a lot, but I'm going to muck with this anyways. So that's how I was able to draw that correctly. I drew the of what as a dotted line, and then I went to the beginning of the dotted line, Braden, and I said, okay, which way do I go? South? Down. North? Up. Or if they had given me east of north, I would have drawn a dotted line north, east, go to the right. West, go to the left. There's a trigger here. Kevin, do you see an angle? Do I see angles? Components. Do I see angles? Components. I'm going to use components. I'm going to break this up into its horizontal, well, it's east-west, and it's north-south components. So I'm going to go like this. I already kind of drew a horizontal line, so I'm going to drop down here. I'll call this its forces, so I'll use the letter Fx and Fy. Kevin, what do you want to find first, Fx or Fy? Doesn't matter, pick. So that's going to be color, adjacent hypotenuse. It's going to be cosine of 30 equals Fx over 24. So it's going to end up being 24 cos 30. And I get 20.78. Because I'm going to be using this, because this is not the answer they asked me to find, I'm going to carry some extra sig figs. There's a 0 after that 6. That's a good place to round off. I'm going to go 20.7846. Carry some extra sig figs. Kev, which trig function is Fy going to be? FYI. Yep. I think this should work out dead even. I think you end up, oh, I wrote Fx, Mr. Dewick. I think you end up with Fy equaling exactly 12, yes? Okay. See the components? So here's my argument. Underneath this, I'm going to put an equal sign as though this is my next line of thinking. And David, what I'm going to argue is the 14 just drops down like a domino. Plus, but instead of drawing that slanty, I'm going to argue that it's made up of a 12 and a 20.7846. I'm going to argue those 3 lines are the original 2 blue lines. Now you might say to yourself, Mason, but Mr. Dewick, now instead of 2 vectors, we're adding 3 vectors. It is true, but which 2 vectors would you add together first if you were clever? Yeah. I can now replace these 2 with 1. I'm going to do that on the next line. I'll put an equal sign. Instead of 14 and 20.7846, that's going to be 1 vector that is 34.7846. What if they were in opposite directions? What would you do? Winner minus loser. Okay, but you could still combine them in 1, is my point. Oh, and the 12 drops down like a domino. Kevin, how many vectors do I have now? And are they at right angles with each other? Pythagoras and SOHCAHTOA. Now I've turned it into something I already know how to do. This is the component method. If you give me a slanty, I break it into components. I don't deal with the slanty angle. Turn it into 3 vectors. Or if they were both slanty, I would end up with 4 vectors, but I'd be able to combine 2 and turn them each into single vectors. And then I add my 2 new vectors, tip to tail. So let's get the final answer. It's going to be yoink. I'll call it F capital R for resultant because we're combining the vectors. Theta goes here, color, 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 color. Dope. Am I wrong? I might be wrong. So you got? Yeah, okay. 36.8 newtons, 19 degrees south of west. So how do I add vectors together? Draw them to detail. How do I subtract vectors? I don't. I turn it into addition question. I add the opposite, keep the first vector the same. What if I have slanty vectors components? I like example 7. I like example 7. I like example 7. Example 7 is a nice question. Example 7, I would consider an A+ level question. This is about as tough as I can throw at you. And here's how I can tell at a glance that this is tough. I saw there's an angle. Did I say angle? Components. And there's something else as well. Read along with me. A plane's speed is 240 meters per second due east. I'll put a compass rose. Crosswind is blowing at 125 meters per second, 40 degrees north of west. What's the plane's velocity relative to the ground? So from our formula sheet, you might recall we said this. The velocity of the engine, or the plane, plus the velocity of the wind, that equals the velocity of the ground. I fibbed a little bit. I said this was an A+ level question. This is an A level question. Because what are they asking me to find, Kai? They're asking me to get this by itself, which already is. An A+ level question would be if I gave you this and the wind speed, wind velocity, and I said find V engine. How would you get the V engine by itself? How would you move the VW over? You'd have to subtract vectors. How would you subtract vectors? You wouldn't. You'd have to add the opposite. That would make it an A+ level question. All right. Kai, what's the engine velocity, magnitude, and direction? What's the crosswind, magnitude, and direction? North of what? North of what? North of what? I'm going to draw west as a dotted line first. I'm going to go north of west, 40 degrees. And I guess this line is 125 at a 40-degree angle. Did I say angle? Components. I'm going to break this up into Vx and Vy. Where my right angle is right there. Color. Kai, what do you want to find first, Vy or Vx? Don't care. Okay. Vy, opposite, adjacent, or hypotenuse? What about the 125? Which trig function? No, A is cosine. This is O. Which trig function? That was a joke. Yeah. Sine, 40 goes next to the trig function, and that's going to be Vy over 12.5. Vy is going to be 12.5 sine 40. Oh, I missed the 0.5, Mr. Duke. 12.5, 125. Mr. Duick, you missed the decimal as well. Wow, you really botched that. 125. 125 sine 40. And I get the vertical component. And since I'm going to use this, I'll carry some extra sig figs. Danica, I'll call it 80.348. 5 sig figs usually gets me there. I'll go more if there's a nice 0 to round off on, but usually otherwise 5 will get me there. 80.348. Oh, Vx. Kai, which trig function am I going to use for Vx? Of course I will. You know what? In the interests of time, because I think it's exactly the same thing, but with cos, I would never do it this way on a test or a quiz, but I think in my homework, I might be tempted to just say, you know what? I can just backspace and edit, and haha, 95.756. And it looks like Vx is pointing west to the left. So here's what I now have. I have 240 this way. I have 95.756 this way. And I have pointing up 80.348. Now in this picture, the scale is garbage. I haven't tried doing things to scale, but I just wanted to get the directions correct. Hey Kai, which two vectors am I going to combine here if I'm clever? How will I combine them? I'm going to go 240 minus 90.756. I think I still have this on my calculators. I'm actually going to go 240 minus, answer button, because why not? And I get 144.244. And I guess still pointing to the right. 144.244 plus 80.348. Whew. So now, Gabor, how am I going to add these two together? Yep. And then I'm home free. Oh, I even got room. Good. You can see why I left you a whole page to work on, or at least for you guys a half page, right? 144.244, 80.348. Ugh, my scale is a bit yucky. Let's do this. And the resultant is going to be something like that. And that's V ground, I think, if I recall. Theta, color. How can I find the magnitude of the ground velocity? By the way, in the industry, they call it ground speed, but it does have both magnitude and direction. They should call it ground velocity, but I'll use the term ground speed because that's what they use in the airline industry, so fine. 144.244. Oh, I got this on my calculator. Answer button squared plus 80.348 squared square root Oh, now I'll go to 3 sig figs in my final answer. 165 meters per second at how many degrees? Opposite, adjacent, tan theta equals opposite over adjacent shift tan opposite (29.1 degrees), and that'll be north of east. I consider that fair game for a quiz. It's just a bit too long for a test. I'll probably give you an airline and a crosswind question, Braden, but it'll be a nice right angle. I'll cook the numbers. Okay? Eight is cool, but I'm going to skip it because I want to give you time to work on this. So what's your homework? 1 is good. 2 is good. 3 is good. Can y'all look at 3A? It says, find the horizontal and vertical components of the following 16 meters north. What's the vertical component of 16 meters north? What's the horizontal component? Be obvious. As a number exactly? 0. Okay. Don't let it panic you. And then 4, you're going to be adding 2 non-right-angled triangles together using the component method. Hey, Mr. Dewick, what other method is there? Using the sine law and the cosine law, add them tip to tail, and it's doable. It's if you're good at the sine law and the cosine law, it's one line faster than the component method. But if you're just really comfortable with SOHCAHTOA trig and can do it in your sleep, then I would just say stick with the component method. But if you want to hit me up during a flex or after school, I can show you the sine law and the cosine law method. It's because I'm really good with the sine law and the cosine law. It's what I use if I'm having to make up an answer key and I don't have room to write anything down and I have to keep track everything on my calculator because it's one less line. But take it or leave it. Vector components. There you go.